Hi guys, this is Rakesh Talreja and I welcome you to BYJU'S exam prep. Heartiest congratulations to all of you on the 77th Independence Day. Yes, our nation has completed 76 years of independence and it should be a matter of pride. It should be a matter of utter joy for all of us, right? Hope you have enjoyed and you have celebrated because it's a national event. We should spend a little bit of time for our nation as well, okay, especially in terms of flag hosting and all. Also at the same time, being a true gate aspirant, okay, what your real independence or what your real freedom will be, okay, seeing yourself successful with the best rank when the finally gate results are announced around 15th March 2024. That's what your eventual dream is, and when you conquer it, okay, you'll be the happiest, and that's where your independence, will really come up from all the pressure, okay, from all the things you might be hearing. Many people also might not be supporting you ki yaar tere se gate hoga ki nahi hoga, but you have that confidence, okay, you'll get the complete mind will be independent from the entire pressure that you are handling right now, okay. So looking into this point of view, it is very important to utilize each and every day. So all the real gate aspirants who are dedicated for each and every day, some of you might have just started gate preparation, some of you might have started maybe 4 or 5 months back. So for a true gate aspirant, we know each and every single day is important, and that is why even on this day the computer science team, okay, we are going to come, we are just in front of you, that is me, Satya sir and Vishal Rabatia sir, okay, and we planned to give you a GATE 2024 mini mock test so that you can sit up, take out a little bit of time today and start solving questions. So what is this mini mock test going to comprise for you? As you know, GATE exact exam is 100 marks, so we have going to convert it into a mini mock today, that is for 50 marks. Yes, you are going to see a test which is going to be for 50 marks. 10 questions will be for 1 mark, 20 questions will be for 2 marks, okay. So total 30 questions, and whenever, what is one rule you can adopt? Whenever I present you a question, okay, looking into the question, you can just pause your screen for a moment, okay, so that you start solving, okay, because I give the question and I keep on also discussing the question simultaneously, right? But if you feel that this is your topic of area and you know it, you can pause, solve it up, okay, and once you are done, then you can start the video again and match whether your answer is correct or not. If not, you can see where you have done the mistake, what is the correct solution, okay, right? From my part, I'll be bringing up the mathematics and digital logic in this particular, and then the other technical areas of computer science will be carried forward by Vishal sir and the Satya sir respectively, okay. So guys, from my side, first question, let's start with engineering maths and then we'll go to digital logic, okay. So consider a non-singular 2 cross 2 square matrix A. If trace of A is 5 and trace of A square is 6, what is going to be the determinant of the matrix A? Now, trace and determinant, okay, related with eigenvalue property, and we should be just knowing simple properties that if A has the eigenvalue lambda 1, lambda 2, okay, why 2 eigenvalues I am writing? Because it's a 2 cross 2 matrix given to you. So A power n has the eigenvalues lambda power n, that is A square will have the eigenvalue lambda 1 square and lambda 2 square, right? Now what is next thing you are given is the trace of the matrix A. The trace of the matrix is known as the sum of eigenvalues lambda 1 plus lambda 2, and that should be equal to 5. And what should be the trace of the matrix? That is A square. Trace of A square will be lambda 1 square plus lambda 2 square, sum of its eigenvalue, and this is given to you as how much? 6. Now what is the determinant of the matrix? Okay, let us just apply the basic A plus B whole square identity. So lambda 1 plus lambda 2 whole square is equal to A square plus B square plus 2AB. Okay, so lambda 1 plus lambda 2 is 5, so I have 5 square is equal to lambda 1 plus lambda 1 square plus lambda 2 square is 6 plus 2 lambda 1 lambda 2. Now what they are asking is determinant, and determinant of a matrix, dear, okay, determinant of any matrix is given by product of the eigenvalues, and the product of eigenvalues, if you calculate from here, okay, that is lambda 1 lambda 2 25 and 6 19, 19 by 2 9.5 is going to be your answer, okay, 9.5 is going to be your answer. So it was a 1 mark numerical answer type question and the answer is 9.5. Is that clear, everybody? Right, moving ahead to the next question, that is the question number 2. A continuous random variable x has the probability density function kx square e power minus x for x greater than 0, otherwise the fx is 0. What is the mean of the x? It's a 2 marks numerical answer type question. Okay, what is going to be the mean of x? But before you start calculating mean, okay, the PDF also you see it's clearly not complete. There is some value k which is missing. Okay, you have to find the value of k, otherwise your answer will be in terms of k and it cannot be solved as numerical answer type. You have to find the final numeric value, so you have to find out the value of k. Okay, and how do you find out the value of k? K itself is missing. To find out the unknown, you can use the basic property of a PDF, that is integral of any PDF is always equal to 1. Integral minus infinity to infinity fx dx is equal to 1. Okay, but here the limit, because x is greater than 0, so the limits will be 0 to infinity k x square e power minus x dx. This should be 1. Now some of you might be feeling, sir, it is going to be a lengthy problem because a lot of integration is going to be involved. But no, I will make it simple if you use the gamma function techniques. Yes, if you use the gamma function technique. So what is the gamma function technique? What is the gamma function? If you recall just quickly, so gamma n is given by integral e power minus x, x raised to the power n minus 1 dx from limit 0 to infinity. Also, gamma n plus 1 is factorial n for any positive integer, for any positive integral value of n, right? For any positive integral value of n. Okay, so I have, okay, now this is k, so e power x, x square, e power x into x square. Okay, so this x square is nothing but n minus 1, x e power x into x power n minus 1. So if n minus 1 is equal to 2, n is equal to 3, and this is nothing but gamma 3. So k gamma 3 is equal to 1, gamma 3 will be factorial 2. Okay, gamma n plus 1 is factorial n, so this is equal to 1, and hence the unknown is solved. 2 factorial is 2, so k is 1 by 2. And now just one more step, mean. Okay, one more step, that is the mean. Okay, which we call it as mean of x, mu of x, right? Or also referred as expected value of x, is given by the general formula integral x fx dx. In general minus infinity to infinity, but here again it is going to be modified limit 0 to infinity x into fx, which is k x square e power minus x dx, right? The k is constant which is outside, and then you are left with the integral again of the form e power minus x is multiplied by x into x square is x cube dx, limit 0 to infinity, and this time n minus 1 is equal to 3, so n is equal to 4, so this is k into gamma 4. You also know the value of k, that is half, and the gamma 4 is factorial 3, and factorial 3 is 6 by 2. The mean value is 3. The answer for the numerical answer type question is 3. The answer for the numerical answer type question is equal to 3. Done hai ji? This final answer is equal to 3. The mean of x is 3 and done. That's it. That's it. The mean of x is equal to 3. Okay, let's move ahead to the next question. Oh, I'm sorry, I think there is a typo error. This was the question number 2. Sorry, this was the question number 2. Now moving ahead to the next. Okay, this was 1, this was 2. 2 questions from maths, that is 1 mark and 1 2 mark. Yeah, definitely some more questions will be from discrete maths. This was engineering maths. For CS, maths means engineering maths plus discrete maths. Okay, but discrete maths question will be added by Vishal sir. Okay, so there will be some more maths question in the form of discrete maths.
Hello dear students, first of all, very warm wishes of 77th Independence Day to all of you. Now, here is your question number 3 from discrete mathematics. Consider a group with 4 elements where every element is inverse of itself. So there are 4 elements and every element is inverse of itself. Then what will be the minimum number of subgroups of group G? So what does it say? 4 elements where, this is important, where every element is inverse of itself. Now it is asking how many minimum number of subgroups will be there for this group G. Right? So let's look at this. Consider the group. Obviously, one element will be identity element because it is a group. And apart from that, there are 3 other elements. This is your group with 4 elements, right? So what are the subgroups of this group G? So please, first is that obviously 2 trivial subgroups will be there. One is G, another is the set containing element E. These are 2 subgroups. Apart from that, in every subgroup, identity element must be present. Now, if we take any element in this set, then will it follow the property of our group? First of all, sir, is it closed? E asterisk E will be E. Now, because every element is inverse of itself, therefore A asterisk A will be E. Therefore, that's the scenario. When A square equals to E, then A is the inverse of itself, right? So, E asterisk E will be E. A asterisk A will also be E, and E asterisk A will be A. So, this set is closed. Operation is associative. Identity element exists. Inverse of E is E. Inverse of A1 is A1. Apart from that, E, A2 and E, A3. Right? So these are the 5 subgroups. These are the 5 subgroups of this group G. Every element is inverse of itself. So how many minimum number of subgroups will be there? So minimum number of subgroups of group G will be 5. Clear? Okay. Let's look at the next question of discrete mathematics. Please pause the video and try to solve this, and then watch the video to get the solution. Okay. Consider the following logical inferences. So there are 2 inferences, I1 and I2. First one says that P implies Q union R, Q implies negation P, R implies negation S, and using these 3 things, you can infer that P implies negation S. Will it be valid or invalid? So that's what we need to say, that whether inference I1 is correct or incorrect. Getting the idea? So that's what we need to check. I1 and I2 is correct or incorrect. So let's try to solve this. What are they? P implies Q union R. Q implies negation P. R implies negation S. And we need to check the validity of P implies negation S. This is one. So another one is negation of P and Q. Q implies P implies R. Therefore, it is asking for negation R. Okay, so these are the 2 things. So first, let's try to solve this one. This one is easy. So first, try to solve this. Negation of P and with Q, then Q implies P implies R. These are the statements. Now, using simplification, you can eventually write it as negation of P, comma Q. This is the simplification, rules of inference. Then Q implies P implies R. Now using modus ponens, this 2 will give you P implies R. Right? Now negation of P is true and P implies R is true. Then this 2 does not give you the negation of R. What is this? This is nothing but fallacy of assuming the inverse, right? So this one is basically invalid. This one is basically invalid. So I can say I2 is not correct. Right? Now let's look for the first one. So these are the 3 things. Now I don't see anything. All of them are implications. I don't know how to solve this. So you can do one thing. that you can apply the conditional proof rule. What does the conditional proof rule says? That if P1, P2, P3 up to Pn logically implies Q implies R, then P1, P2, P3 up to Pn, and assume the antecedent of the implication in the set of premises, this will eventually logically imply your consequence, that is R, right? So rather than proving this first one, if we can prove the second one, then both these statements are same. So let's look at this. P implies, so the hypothesis will become P implies Q or with R. Q implies negation of P. R implies negation of S. And let's assume that P is in the set of hypotheses, and from here let us try to conclude that this thing gives negation of S. Now let's check for this. Sir, this two, P, and you can actually write it as, P implies negation of Q. So P implies Q is negation of Q implies negation of P, therefore Q implies negation P will be negation of P. Negation of P implies negation of Q, that is P implies negation of Q. Now this two by modus ponens will give you negation of Q. This two by modus ponens will give you negation of Q. And again P implies Q union R, and P again modus ponens will give you Q or with R. Now Q or with R is true and negation Q is true, means Q is false. Negation of Q is true means Q is false. So if Q is false, then for Q union R to be true, R must be true. Getting the idea? Now if R is true and R negation of S is true, then again by modus ponens negation of S will be true. So getting the idea that first one is valid, that whenever these three statements are true, P implies negation S will also be true. But the second one is invalid, that whenever these two statements are true, we cannot comment about the truth value of proposition R. Clear? So sir, I2 is not correct, I1 is correct. Clear? So both I1 and I2 are correct? No, I1 is correct, but I2 is not correct inference. Yes, statement B or option B is the correct option. Let's look at the third question. Consider a set A such that cardinality of A is 5. So cardinality of set A is 5. Then number of equivalence relation of cardinality 8. That is the number of equivalence relation in which the number of elements are 8 on set A will be how many? So please try to understand this. But okay, let's assume that set A is nothing but a set with 5 elements, 1, 2, 3, 4, 5. Clear? Now, if you define an equivalence relation R1 such that the cardinality of R1 is 8, then equivalence relation, first of all, it is an equivalence relation. So 5 elements are already known to us because the relation has to be reflexive. Therefore, 1, 1, 2, 2, 3, 3, 4, 4 and 5, 5. These 5 elements will definitely be present in every equivalence relation of size 8. Apart from that, you need to choose 3 more order pairs. Such that relation follows relation it eventually satisfies the condition of what? Relation satisfies the condition that the cardinality of the relation is 8. So what is an equivalence relation? An equivalence relation is reflexive, symmetric and transitive. reflexive, symmetric, and transitive. So, what will be the answer for this question? Please think. See, sir, for equivalence relation, it should be reflexive. So, yes, this 5 order pairs will definitely be present there. Sir, now symmetric. If you take the pair 1, 2, if you take the pair 1, 2, then it is necessary that you also take the pair 2, 1 for it to become symmetric. Okay, sir. So this 2 will be present 1, 2, 2, 1. Now, if I take any other pair 1, 3, then for it to be symmetric, I will also have to include 3, 1. That means the number of elements in this symmetric relation such that it is reflexive will become 9. So, I hope you understand that on a set A with 5 elements, there cannot be any equivalence relation. There cannot be any equivalence relation which consists of 8 order pairs. So, the number of equivalence relation of cardinality 8 on set A is guaranteed to be 0. What the idea? Clear? So, this is the simple information related to this particular concept. Yeah, I can make this question more interesting if I give you some other number. Let's assume if I give you the value as a 9. If I give you the value as 9, or let's assume, let's keep it simple. If I give you the value as 7, then how many equivalence relation are there of cardinality 7 on this set A with 5 elements? Then the answer will become, sir, for 7 elements, what will happen? So 5 diagonal order pairs will be present, and apart from that, for every non-diagonal order pair 1, 2, its symmetric order pair 2, A should also be present. So such 2 pairs can be chosen in how many ways out of this 5 elements? So basically, we can choose 2 elements out of this 5 elements of set A in 5C2 ways, and 5C2 is basically nothing but 10. So such 10 symmetric order pairs can be included along with this 5 order pairs, and there will be exactly 10 equivalence relation on this set A of cardinality 7. Similarly, we can define the number of equivalence relation on set A of cardinality 9, then we can define of cardinality 11, etc. Right? So that's the basic thing, that okay, but for this given question, the answer will be 0. Clear? I hope it's understood to everybody.
Hello. So here is question number 6 of Independence Day special mini mock test for GATE 2024 computer science aspirants. The question is, what will be the output of the C program? And this question carries 2 marks, dear friends. So go through the program carefully. You may pause your video and try to solve and give the answer in the chat box, or else in the comment section. Let's see what is the answer for this. Given int A, B, C. Int array of 5, values are 1, 2, 3, 25, 7. A equal to plus plus ARR of 1, B equal to ARR of 1 plus plus, C equal to ARR of A plus plus. Print A, B, C. So let us solve. Let us take an array with 5 elements. Values are 1, 2, 3, 25, 7. Indices are 0, 1, 2, 3 and 4. Now, A equal to plus plus ARR of 1. It is pre-increment. What is ARR of 1? This is ARR of 1. Right? Increment it. So this becomes 3, and what would be A value? A value would be 3. Then B equal to ARR of 1 plus plus. This is post increment. So first the value at ARR of 1 is retrieved, that is 3. So that 3 is assigned to B, and then it is incremented. Now C is equal to ARR of A plus plus. A plus plus is again post increment. So ARR of A, what is A? 3. So ARR of 3. That means what would be C value? 25. So A is 3, B is 3, C is 25 gets printed. Option B is the right answer for this question. Understood? Question number 7. What will be the output if you will compile and execute the following C code? And this question carries 1 mark. Pause it, then solve and give your answer first, then you can verify it. Okay? We are printing -2 of array. Here array has the values 10, 20, 30 and 40. Right? Now -2 of array, somebody might think array -2. No, it is -2 of array. Minus is a sign here. So minus, it is equal to array of 2. What is array of 2? 30. So minus 30 would be the value. Option B is the right answer for this question. Okay. Question number 8. The second leaf node in min heap after construction with elements so and so inserted in that order is. It's a numerical answer type question for 2 marks. Come on everybody. Pause it before you go for the solution. Pause it, solve you first, then look at the solution. Okay. So let us construct. First insert 10. One node, so it is definitely complete binary tree balanced. Complete binary tree. And 7 is less than 10, so it would be left side to 10. Then 8 is greater than 7. Right? Wait a minute. We want min heap, right? Min heap. So min heap means parent must be smaller than its children. So for 10, whenever you insert at the left side, 7 is smaller. So you have to swap 7 and 10. Then insert 8. Yes, it is complete binary tree. Then insert 9. To satisfy CBT property, you will insert 9 at the left of 10. But it is smaller than its parent, hence 9 and 10 are swapped. Nine and 10 are swapped. Okay. Then insert 3. Where you insert 3 as right to 9. Here heapify. So 3 and 9 will be swapped. Then 3 and 7 would be swapped. Right? Then insert 2. 3, 7, 8, 10, 9. Insert 2. Where do you insert 2? Here. Swap to heapify. Again swap with 3. Right? Then insert 6. Where do you insert 6? As right to 3. Yes, it is satisfying min heap property. Now insert 12. Here you insert 12. Then insert 15. Insert 13. Because they are satisfying the structuring property, ordering property with 12, 15, 13 instruction. So it is the final min heap we have got. Right? Now what is the second leaf node? Second leaf node. 8 is the first leaf node. 6 is the second leaf node. 12 is the third leaf node. 15 is the fourth leaf node. 13 is the fifth leaf node. So what is the second leaf node? 6. Understood? Question number 9. What does the following function do for a given linked list with first node as head? Look at the code and options. This question carry 2 marks. Pause this, solve it, then you check the solution. Okay? To analyze this code, let us take one example. Let us take one example. Let A, B, C, D, E and F. Let's say these are the nodes in the linked list. Head is pointing at A. Now, if head equal to null, no. If head is null, return. As it is not, print head data. So, A gets printed. Fun one of head next next. So, where head goes, head next is B. B next is C. So, here comes head. Right? Is it null? No. So, print head data. Go to head next next. Is it null? No. So, print head data and go to head next next. Now head is pointing to null. So here it ends. So what got printed? Alternate nodes got printed, right? So it prints alternate nodes of the linked list. Understood? Great. So let's proceed to next question.
Okay, now the third question, I'll move from digital logic. Okay, the function f is designed with the decoder and multiplexer as shown in the figure. What is the minterm of fpqr? Okay, what is the minterm of this given function? So it's a fundamental question based on the combination of decoder and multiplexer. Okay, the inputs to the decoder are pq. Okay, and the multiplexer has the select line pr. So we know that how to write down the output of this 4x1 multiplexer when the select line 0 0 0 0 means p bar r bar. Okay, at the select line 0 0, what is selected? I naught. Ye dekhna, I naught, that is equal to, now what is the value of I naught? It is the y naught output of decoder, and that should be p bar q bar. Similarly, y1 output is p bar q, y2 is p q bar, and y3 is pq. These are the four outputs of a 2x4 decoder in accordance with 0 0 0 1 1 0 and 1 1, right? So at the 0 0 select line, I naught should be selected, and I naught is equal to p bar q bar, right, plus 0 1 I1, that is p bar q, plus 1 0, select line 1 0 means pr bar, with 1 0 I2 is selected, that is pq bar, okay, plus select line 1 1, that is pr, and with that I3 is selected, which is further equal to pq, right? So the f expression, actually the f expression, now p bar into p bar is p bar only, so p bar r bar q, okay, p bar r bar q, correct, plus I have next p bar r p bar q, so p bar into p bar is again 1, so p bar r q, plus p into p is 1, so p r bar q bar, plus p into p is 1, so p r q. Now maybe some of the terms, I'm not telling sure, maybe some of the terms can be simplified, but should you simplify? No, because you are asked the minterm expression, okay, the canonical SOP expression, minterm expression, you should not simplify here. So what is this simply now? Okay, this is simply 0 0 1. Okay, acha, we need in the form of pqr, I'm sorry, so let's arrange in the form of pqr. Let's arrange this in the form of pqr only. So this becomes equal to p bar q bar r bar, next is p bar qr, next is p q bar r bar, and next is p q r, right? And these are what minterms? These are summation of the minterms. 0 0 0, p bar q bar means 0 0 0, which is 0. Then we have 0 1 1, p bar q r 0 1 1 3, p q bar r bar 1 0 0 4, and p q r is 1 1 1, that is 7. 0 3 4 7, 0 3 4 7 are the minterms coming up. Okay, so option number A clearly matched, right? 0 3 4 7, option number A clearly matched. Moving ahead with the question number 4. Okay, the truth table for a AB flip-flop, some random AB flip-flop I want to design. It's not a JK or a SR or something like that. Okay, I want to design, and the truth table for that flip-flop which I want to design is given to you. Okay, so that whenever the input is 0 0, I want the output to be set. Whenever 0 1, I want the output to be same. Qn plus 1 is Qn. At 1 0, I want toggle complement state. At 1 1, I want the flip-flop to reset. Okay, right? Now if this flip-flop is to be designed, implemented using JK flip-flop, now we have JK flip-flop, D flip-flop, SRT flip-flop available. Using them, I am designing some AB flip-flop. Okay, what should be the input to the JK flip-flop so that this functionality is obtained? Now, आप ऐसे देखो, what you have to do is, you have to design it. You have to design it using JK flip-flop. Okay, you have to design it using the JK flip-flop. Okay, so let me extend this table and let me make the entries of JK. Okay, right now you look into this much of the section. Okay, for the given transition Qn plus 1 equal to 1, what should be JK? Do you know? Yes, you should know this. Qn plus 1 equal to 1, that is the set state condition. This is set, this is same, this is toggle condition, and this is the reset condition. Okay, to set the JK flip-flop, J1 and K0. To reset, K should be 1, J should be 0, J0, K1. For the same state combination, okay, J and K 0. To toggle, J and K both 1. This should be the jk value as per your knowledge, okay, to implement this qn plus 1. Okay, now write down the j and k as the function of a and b. Write down the j and k as the function of a and b. Write down the j and k as the function of a and b. लिख के देखते हैं, as a function of a and b. So right, what is j? What is j? It is high at ab 0 0, that is a bar b bar, plus at 1 0, at 1 0, that is a b bar. Now b bar is common out of this, and then a bar plus a we all know should be 1. So it is b bar into 1, which should be equal to b bar. Okay, similarly k is high at the last two, that is 1 0 and 1 1. 1 0 means a b bar, 1 1 means a b, right? Out of this a is common, and then b bar plus b will be equal to 1. So answer is just a. So what should be j is b bar, k should be a. What is the correct option? The j is equal to b bar and k is equal to a. Option number B. J is b bar, k equal to a. It will behave as a AB flip-flop, right everybody? It will be behaving as a AB flip-flop in that case. It will be behaving as the AB flip-flop in that particular case, right? If you want to understand from a design point of view also, so suppose you have a JK flip-flop. Okay, let me take positive edge triggered or anything you can take. Okay, this is the QN output, the current output, and then QN bar, right? But what is J is B bar and K is equal to, I was designing a AB flip-flop. This is my A input, right, which will actually go to K. My A input will actually go to K, right? And the another one is B input, and the B bar will go to J. The B bar will go to J. Okay, this is what is, see, they're not asking the diagram, but just for their clarity, this is what is a AB flip-flop implemented using a JK flip-flop. Okay, next. Okay, question number 5. Which of the following is true for the following function? Okay, a function ABCD, summation of the minterm, a minterm list is given to you, and we have to comment on how many essential prime implicants or how many prime implicants, how many redundant prime implicants, okay, etc. Okay, and you know the best method of handling the prime implicants, again K-map, that is a shortcut rather than going for the tabular method. Okay, so let us consider the 4 variable map here. Just a second, I think there is a slight issue here. All right, okay, so you just have to make the entries first into the K map. Yeah, okay. Okay, so as always, let's take the AB here and CD here, and yeah, 0 0 0 1 1 0 1 1, sorry, gray code, 1 1 and 1 0, 0 0 0 1 1 1 and 1 0. Okay, and then accordingly these are the two places where A is high, B is high at the center too, so we can call this as the B portion. C is high, CD is high at the last two columns, and D is high. Here I have 1 1. D is high at the center two columns. This is what is D. Okay. Now, what are the minterms given? 0 2 3, 0 2 3. Okay, let me just keep making the entries of that. 0 2 3. So this is 0 2 3. Then 5 7, 4 5 6 7. Then you have 8 9 10 11, 8 9 10 11, and then you have 13 and 15, 13 14 15. Okay, we should all know that because of the gray codes, the last two columns are interchanged, the last two rows are interchanged. Okay, we have 0 1 2 and 3, like that, 2 and 3. Okay, okay, 4 5 6 7. This is how we name the minterms. So hope you are clear about that. Okay, right, you must have learned before the K maps and the prime implicant. Chalo, now how many prime implicants, how many essential prime implicants? Prime implicant means all possible groups. Okay, what is the shortcut from prime implicants? All possible groups that you can make out of this K map. Okay, all possible group, whether it is to be taken in final function or not, wo nahi sochna hai abhi. All possible. Sorry, I think there was some voice interruption in between. Okay, but now it is okay. So till now what we have done is, let me quickly recap that. Till now what you have done is, you have find out all possible groups that can be made. Okay, all possible groups that can be made in the K-map. All such groups are pi, and we have done the 6 PIs. Okay, again I repeat, like these two ones and these two ones, they make pair, but pair adjacent is a quad, so you can't take the pair, you have to take the quad only, the largest possible group. Okay, and we have made 6 such cases. This is one quad. Then look into this again, this is one quad, right? Then this third column, this is one quad. The fourth row, that is the next quad, 4. The fifth one is the corner ones. Okay, all the corner ones, they are adjacent, that is the fifth one. And what is the next quad I have taken? Look into this. Okay, 1 1 adjacent, because first and last rows are adjacent. Okay, so these are the 6 PIs. Now coming to EPIs. Okay, EPIs, what is the method for EPIs? Okay, now you will start highlighting. Okay, you will start highlighting the minterms which are covered under a single group. You will start highlighting the minterms which are covered under a single group. Okay, let me highlight this. Okay, this is covered under multiple groups. This is covered under multiple groups. Okay, this minterm, this is under a single group, under a single prime implicant. This is under 2, this is under multiple, this is also under multiple, ye bhi multiple mein hai, ye bhi multiple pe. Okay, now the method is highlight those minterms which are covered under multiple, which are covered only under single PI, only under single group. And that group, that PI becomes essential for you. Okay, that PI becomes essential for you. So what is the list of EPIs then? What is the list of EPIs, right? So there are this one, this is the corner one, B bar, D bar, this becomes, okay, and the center one, BD, the center one, BD, okay, this becomes the essential. Okay, so there are 2 essential prime implicants, that is the BD and B bar, D bar, right? That means option number A is also correct. BD and B bar, D bar, look into the option number D. BD and B bar, D bar are the prime implicant as well as essential prime implicant. So D option is also correct. How many redundant prime implicants will be there? Okay, now how to find out the redundant prime implicant? Okay, some prime implicants are essential. Okay, 2 are essential, 4 are non-essential. Out of the non-essential also, some are selective, some are redundant. Okay, now to make you explain the selective and redundant, I'll have to draw this K-map once again so that you have a neat and clean picture. Already a lot of things have been placed here, so I'm just redrawing the K-map. Okay, just listen to it patiently, so that you understand what is selective prime implicant, what is redundant prime implicant. Okay, let me make that K-map once again and let me get that entries again. So I have the entries, then I have these 2, correct, 8 9 10 11, correct. Okay, so now suppose you are trying to find out the minimum function, the f minimum, the minimized form of the function using the K-map. Okay, again let me put that this is A, this was named as B, this was C, this was D. Okay, now if you are trying to answer it using the K-map, okay, okay, first of all I told you there are 2 prime implicants that 100% to be taken, that is BD, okay, that is BD and B bar, D bar. This is essential. Okay, essential means zaruri, iske bina kaam nahi chalega, right? But tell me dear, okay, what is the function expression? What is the minimized expression of the function? Is it only equal to BD plus B bar, D bar? Is it only equal to BD plus B bar, D bar? If you only take BD plus B bar, D bar, this minterm is missing. These 2 minterms are missing. So kya karenge? Right? Kya karenge? Okay, so I'll tell you the options kya karenge. Okay. Let me again write down, this is the BD essential prime implicant and this one is the B bar, D bar essential prime implicant. Okay, now to cover up this minterm, okay, there are how many options? To cover up this minterm, okay, one option is ye wala quad. One option is ye wala quad. Okay, what is this quad? What is this quad? Is minterm ko cover karne ke liye. Now what is this quad? B bar C. Okay, you can take B bar C or the third column. You can take even this quad, so this minterm will be covered. That is the third column. That is the third column. That is the CD. Okay, so I can write down the function as plus, right? B bar C or CD, any one of them, plus. Now still these 2 minterms are missing. Okay, yeah, chalo, even if you take the third column, still this is missing. Okay, what are the ways to save this? So now to save this, to save this midterm, you can take either the fourth row wala prime implicant. Okay, what is the fourth row prime implicant was named as? Okay, AB bar, correct. You can take AB bar, or what else you can take? Okay, maybe you can take this quad. Okay, that is AD. You can take AD. Okay, so next possibility is AB bar, right, or AD. Okay, now try to understand. Okay, you have 6 PIs, right, and out of them 2 were essential. 2 essential PIs. Okay, so 4 non-essential. 4 are non-essential. Non-essential prime implicants are qualified into selective and redundant. Okay, now out of the 4, okay, any 2 you will select. One from here, one from here. Okay, any 2, your choice. Okay, somebody can select B bar C plus AB bar, somebody can select B bar C plus AD, somebody can select CD plus AB bar. Everything is okay. All answers will be correct. But how many you will select? One from here, one from here, right? So 2 will be selective. Okay, now if you select 2, definitely you are rejecting the other 2. Okay, you are reducing it. That will be known as redundant. 2 will be redundant. Okay, that are known as RPIs. Okay, this is known as RPIs and this is known as SPI. Selective prime implicant, redundant prime implicant. So how many redundant prime implicant will be there? 2 redundant prime implicant will be there. Okay, so this is wrong. But the correct answer is A, B and D. It's a MSQ question, that is why it took a little bit time. Okay, but yeah, definitely MSQ, especially computer science, it's expected asking around 12-15 MSQs in computer science mostly. Okay, and that can be from digital logic as well. So this was one such MSQ from the digital logic, right guys? And now Vishal sir, okay, will come up and add up to some more questions from, discrete maths and what else he'll add on, COA and etc. Okay, and then Satya sir will join. Okay guys, so now quickly on screen you will see Vishal sir. Once again, heartiest congratulations from my side on the 77th Independence Day, and keep preparing and keep shining with your preparation. Okay, of course, if you keep shining with your preparation progress, you will be shining in the results as well. Okay, every day matter, every particular effort matters, and day by day you need to have that growth. Okay, so happy Independence Day. Vishal sir will be just in front of you now. Thank you.
Okay, so here is your question number 13 from the subject Computer Organization and Architecture for this particular test. Now, let's read the question. Different addressing modes are used to access the operands. Frequency of addressing mode used to fetch an operand is as given. What does it mean? So, 20% of time when we are accessing an operand, the used addressing mode is register addressing mode. 15% of time, the used addressing mode is direct addressing mode. 40% of time, the addressing mode used is register and direct addressing mode, and 25% of time, the addressing mode used is indexed addressing mode. Now, if memory access takes 3 cycles, register accessing takes 1 cycle, and arithmetic operation takes 2 cycles, then the average number of cycles needed to fetch one operand. Average number of cycles needed to fetch one operand. So please try to understand that when we access the operand using the register addressing mode, there will be only one register access involved in that, right? Using direct addressing mode, there will be one memory access will be performed. If it is register indirect addressing mode, so first you will access the register to get the effective address, and then based on that effective address you will perform the memory operation. Therefore, one register access will be required using register indirect addressing mode, and one memory access will be required after getting the effective address. Now, index addressing mode. So in index addressing mode, one register access will be required to get the index value. Then one arithmetic operation will be required. Yes or no? In index addressing mode, the value or the address present in the address field of instruction is added with the content of the register. Clear? So this two will be added. That means, the value present in the address field of instruction and the register value will be added. Therefore, arithmetic operation will be required. After the addition, you will get the effective address, and based on that address, one memory access needs to be performed. Clear? So that's the concept. Now it is asking that, and we know that, okay, if the operand is accessed from register, it will require only one clock cycle. If the operand is accessed using from memory, then it will require 3 memory cycle. But if it is a register indirect addressing mode, then first you will access a register to get the effective address, then you will access the memory. That means one register plus one memory. That is the number of cycles. Okay, let me define. If the addressing mode is register addressing mode, then the number of cycles needed to fetch the operand will be only 1, because register accessing takes only 1 cycle. If addressing mode is direct addressing mode, then the number of cycles needed will be 3. That is, 1 memory access will be required to fetch the operand, and 1 memory access takes 3 cycles. If the addressing mode is register addressing mode, then first of all, 1 cycle will be required to access the register, and then 3 cycles will be required to access the memory. That is, 4 cycles will be needed using register indirect addressing mode, and using index addressing mode, first of all, 1 cycle will be needed to get the to fetch the index register, then 2 cycles will be needed to perform the arithmetic operation, and then finally 3 cycles will be needed to fetch the operand from the memory. That is, 6 cycles will be needed. Now, so what is average number of cycles needed? So guys, if you look at this, that 20% of time means with respect to one instruction with fraction 0.2, it is a possibility that it will be a register, it will be using register addressing mode. So with fraction 0.2, you will require 1 clock cycle, plus with fraction 0.15, it is using memory direct addressing mode, and in that case it will require 3 clock cycles, plus the possibility that it is using register indirect addressing mode is 40%. Therefore, with fraction 0.4, it will be requiring 4 clock cycles. Or with fraction 0.25, it will use index addressing mode, and in that case it will require 6 clock cycles. If you add them, what will it be? So this is nothing but 0.2 plus 0.45 plus 44, 1.6 plus this will be 1.5. So the value is 1.5, 1.5, 3.1, 3.3, 3.75. So the average number of cycles needed to fetch one operand, if these are the specification, will be 3.75. Clear? Okay, let's move to the next question of computer organization and architecture, COA. So this is your question number 14. Pause the video, try to solve the question, and then play the video to watch the solution. Okay, so it says, consider a machine with hit rate of read and write operation on cache as 0.5 and 0.4 respectively. So what is given? If we are going to perform a read operation, the cache hit rate will be 0.5. If we are going to perform a write operation, then the cache hit rate will be 0.4. Let access time of cache is 20 nanosecond and main memory is 100 nanosecond. Okay. If cache uses write through updating technique, so if you are using write through updating technique, then there will be no inconsistency in the content available in the main memory and the content available in the cache, because in write through updating technique we perform simultaneous write operation. What do I mean by simultaneous write operation? Simultaneous write operation means we'll perform the write operation in the cache as well as in the main memory. Clear? Then absolute difference between average access time of read operation and average access time of write operation is. So let's try this. So what do we know? So hit ratio for read operation is given as 0.5 and for write it is given as 0.5. Hit ratio of write operation is given as 0.5. What do we know? Time to access the cache is given as 20 nanosecond. Time to access the main memory is given as 100 nanosecond. And the updating technique is a write through. By default, write through is with write allocate. There are two different methods to implement write through. If nothing is given in the question, then by default approach will be with write allocate. Clear? Okay. So what will be the average access time to perform the read operation? So first of all, you will look into the cache. So with rate 0.5, it will be hit in the cache. If it is a hit in the cache, then you can simply read from cache. And the time to read from cache will be 20 nanosecond. Or it will be miss with rate 0.5 only, because miss rate will also be 1 minus 0.5. So it will be miss in cache with rate 0.5. And if it is a miss in the cache, then first we need to read allocate the block, that is transfer the block from the main memory to cache, and that will require the main memory access time, that is 100 nanosecond. And finally, after read allocating the block, you will access the data from the cache only. So this will be the time required to perform a read operation. So what will it be? 525, this is 10, then 125, this will be 60. So 70 on an average for one read operation, you will require 70 nanosecond using the above configuration. So what will be the average access time to perform the write operation? So with respect to write, the hit ratio of write operation is 0.4, I guess. Hit ratio of write operation is 0.4. Yes, it is not 0.5. This is given as 0.4. Right? So with rate 0.4, it will be hit in the cache. But it is a write through cache, therefore it will perform the simultaneous write operation. That is, it will perform the write operation in the cache as well as in the main memory simultaneously. And we will assume that the operation is complete when the memory which is taking more time has been updated, and the more time will be with respect to main memory. So with rate 0.4, it will require 100 nanosecond, or it will be a miss in the cache while trying to perform the write operation, and it will be miss with rate 0.6. And in case of miss, first you need to write allocate the block. Write allocate the block means transfer the block from main memory to cache for the purpose of writing, and that will require 100 nanosecond. After write allocating the block, you will perform the simultaneous write operation. Simultaneous write operation will again take main memory. So if you are worried, then this is nothing but TC, this is TM, this is TC, this is trying to perform the simultaneous write operation. This is time to read allocate the block. This is time to perform the simultaneous write operation. Let's say simultaneous write operation के लिए जो time लग रहा है, let me call it TW. Clear? So what will be the time? So 100 into 0.4 will be 40 plus this is 200, 0.6, 120. So the time required will be 160 nanosecond for the write operation. Now it is asking for the absolute difference between the average access time of read operation and the average access time of write operation. So it is nothing but 70 minus 160, that is minus 90 or 90. So finally the answer is 90 nanosecond. Clear? This will be your answer for question number 40. Okay. let's move to the next question. That is question number 15 of COA. This is quite similar to a question which has been asked in the GATE exam, but I'm considering this question because this have a very specific information to calculate the average access time. The average CPI, and that's what you should know, right? So let's try to understand. So first of all, pause the video, try to solve the question, and then play the video to watch the solution. In a given program, assume that 20% are memory instructions, 50% are ALU instructions, and rest are branch instruction. 20, 50 rest. Right? So what do we know? In our program, 20% memory, 50% ALU, and rest are branch, means so rest means 30% left out of 100% instructions, branch instructions. Okay, sir. What else is given? 5% of the memory instruction causes stalls of 40 clock cycles. Now, please read the question first. 5% of the memory instruction causes 40 clock cycles stalls, each due to cache misses. Okay, and that will happen because of miss in the cache. 60% of the branch instructions causes stalls of 2 cycles each. So whenever you are executing branch instructions, 60% of those will eventually cause these stall cycles, and they will cause 2 stall cycles each. Now, when you are executing ALU instruction, there will not be any stall. That means there will be no problem in the pipeline because of the execution of ALU instructions. Now, apart from that, also assume that no other data hazard or resource conflict exists in the pipeline. Data hazard or resource conflict, no other exists in the pipeline. So, see, please try to understand if there are no stalls in the pipeline, right? So, if no stalls, in pipeline, then what is the average CPI? Then average number of cycles needed per instruction in the pipeline will be 1. That's the consideration of average CPI. Basically, it's nothing but, sir, eventually, how many cycles are needed? So k plus n minus 1 cycles are needed for the execution of n instruction on a k stage pipeline, and overall for n instructions. So if the value of n is very large, then k plus n minus 1 will be almost n, k plus n minus 1 will be almost n, and divided by n will come out as 1. So that's the concept of thinking that average CPI is 1, and we always assume that large number of instructions are pipelined until unless specified otherwise. Okay, so here in this particular question it is saying that 50%, right? No, 5% of memory instruction causes 40 stall cycles. So with respect to them, out of this 20% memory instructions, 5% will cause 40 stalls or stall cycles. Out of this 50%, 0% will cause a stall. No stall cycles are present because of ALU instruction. Out of this 30% branch instruction, how many? 60% of the branch instruction. 60% of this branch instruction will cause 2 stall cycles. So if I ask you that what will be the average number of stalls, average number of stall cycles per instruction. So sir, with rate 0.2, it will be a memory instruction, and in that case, there will be no stall cycle associated with the 95% of instructions, but with respect to this 5% of instruction, that is with respect to this 0.2, 0.05, 0.5, 5%, that is 0.05. right? So out of those 20% memory instruction, 95% will not cause any stall cycles, but the 5% of them will cause 40 stall cycles. So because of them, 40 stall cycles will be created. Plus, out of this 50% ALU instructions, that is with rate 0.5, it will be an ALU instruction and it will not cause any stall cycle. 0 stall cycles because of ALU instruction. Plus, with fraction 0.6, it will be a branch instruction and 60% of the branch instruction, 60% of the branch instruction will cause 2 stall cycles. Leave it, right? So these are the number of stalls per instruction. That if we divide the total number of stalls in equally in every instruction, then those many stalls will be there for every instruction. So what is this value? Let me calculate this. 0.2 into 0.05 into 40. So this will be 0.4 plus 0 plus 0.6 into 0.6 to 30, 30, 30, 30, 30, 30, 30. This is 30% of the branch instruction. This will come out as 0.3. Please make this correction, that these are the 20% instruction, these are 50% instruction and 30% branch instruction. Out of those 30%, 60% will cause 2 stall cycles. So I would say 0.3 into 0.6 into 2, so 0.36. So sir, on the overall instruction, the average number of stalls per instruction will be 0.76. These are the average number of stalls per instruction. So what will be average CPI? The question is asking for average CPI, that average number of cycles needed for the execution of an instruction of the program means nothing but average CPI. So average CPI will be nothing but average CPI is ideal CPI, that is the CPI in case of no stall cycles plus number of stalls per instruction. On an average, how many stalls are observed per instruction? So how many stall cycles are observed per instruction? So 1 is the ideal CPI and the number of stalls observed per instruction will be 0.76. Will be 0.76. So the final answer will be 1.76, that on an average 1.76 cycles will be needed for the execution of an instruction of this program if these are the specifications. Clear? That is your question number 15. Let's move to the next question.
Question number 16 of Independence Day special mini mock test for GATE aspirants. The question is here. Consider specifications below. Main memory size 4 GB, virtual memory size 1 GB, frame size 8 kilobyte. The length of virtual address and physical address are dash and dash bits respectively. It is a 2 marks question, dear friends. So pause. First you solve it, then look for the solution. Main memory size given 4 gigabyte. Virtual memory size given 1 gigabyte. Frame size given 8 kilobyte. Right? What is what is main memory size? 4 gigabytes. That means 2 square multiplied by 2 power 30. 2 raised to 32 bytes. So from this we can say the physical address length is 32 bits. And what is virtual memory size? 1 gigabyte. That is 2 power 30 bytes. So virtual address length is 30 bits. So virtual address and physical address in this order we want. So it is 30 comma 32. 30 comma 32 is the right answer. Clear? Question number 17. Consider the process table given below. Find the sequence of process completion using HRRN scheduling. Here we have options and the processes table given. This is 2 marks question. First you solve it, dear friends, then continue watching the solution. Okay. This is processes information given. Now let us try to draw the Gantt chart. At time 0, we have process A only available, and HRRN is non-preemptive scheduling algorithm. So let it go. Now at time 2, we have only one process arrived, that is B. So we have no other process, so schedule B. Now the time is 9. C, D, E have arrived meanwhile. So at time C, at time t equal to 9, C, D, E, what to schedule? Calculate the response ratio. Response ratio of C. What is response ratio? Burst time plus response time divided by burst time. So what is response ratio of C? Burst time is 4. It arrived at 4 and the time now is 9. So 4 to 9 is waiting. So 5 is the response time divided by 4, 9 divided by 4. And D response ratio 5 plus 6 to 9 means 3 divided by 5, 8 by 5. And E response ratio 2 plus 1 divided by 2, 3 by 2. So 9 by 4 means 2.25, 1.6, 1.5. So it is having highest response ratio C. So schedule C, 9 to 13. Now at time t is equal to 13, we have DE. So calculate the response ratio of D. 5 plus 7 divided by 5. From 6 to 13 waiting is 7. Right? So this is 12 divided by 5, 2.4. E response ratio is 2 plus 5 divided by 2, 7 by 2, 3.5. So this is highest. Which one? E. So E would be scheduled next, 13 to 15. Then only one process is left, that is D. So 15 to 20. So A, B, C, E, D is the processes completion sequence. A, B, C, E, D. Option D is the right answer. Got it? Question number 18. A process execute the following code. The total number of child processes created is. It's a numerical answer type question, 1 mark question. Pause the video. First you solve for yourself, then check the solution. Come on. I equal to 1, I less than 14, I plus is equal to I plus 2, fork. So first, when I is equal to 1, 1 less than 14 true, so fork. One time fork is called. Then I becomes I plus 2. 1 plus 1 plus 2, that is 4. 4 less than 14, true, fork. Now I becomes I plus 2, 4 plus 4 plus 2, 10. 10 less than 14 is true. So fork. Now I becomes 10 plus 10 plus 2, 22. 22 less than 14, false. So number of times fork is executed, 3. So number of fork calls, 3. So total number of child processes would be 2 cube minus 1, that is 7. So the answer is 7. Understood? Let's proceed to next question. Question number 19 of Independence Day special mini mock test for GATE 2024 aspirants. Here is the question. Suppose P, Q, R, S, T are sorted sequences having lengths 20, 24, 30, 35, 50 respectively. They are to be merged into a single sequence by merging two sequences at a time. The number of comparisons that will be needed in the worst case by the optimal merge algorithm for doing this is. It's a NEAT question for 2 marks. Pause it, solve it, then check the solution. Here we have 5 sorted sequences P, Q, R, S, T. As per the optimal merge sequence, when two arrays A of length M and B of length N merged, then number of comparisons would be, we can say, M plus N minus 1. So here first we are merging P and Q. P and Q, when you merge, it produces 44 elements sequence, but the number of comparisons would be 43. Now, S, R and S. R is of 30 numbers, S is of 35, because in the optimal merge, two smallest elements are merged. So here than 44, 30, 35 are smaller, so we will merge these two. This produces 65 elements list, but the comparisons would be 64. Okay. Now, among 44, 65 and T, 50, which are small, 44 and 50 are small. So, merge this and T. That produces 44 plus 50, 94 elements list. Right? Wait, let me draw like this. (44) and 50 elements list, when you merge, it produces 94 elements list, but the number of comparisons would be 93. Now finally we merge this 65 and 94, that produces 159 elements list, but the number of comparisons 158. So in the worst case, the number of comparisons would be 158. That is the answer. Got it? Question number 20. MSQ question, multiple select question for 2 marks. Consider 4 matrices P, Q, R and S with orders 2 by 3, 3 by 4, 4 by 3 and 3 by 2. The first product that can be happened in order to obtain the result in optimum number of multiplications is. 1 may be correct, 2 may be correct, 3 may be correct, 4 may be correct. Pause it. First you solve it, then check the solution. Okay. So here we can apply the matrix chain multiplication dynamic programming method, definitely, but it takes a lot time, as in the GATE exam time is more precious. We can solve it simply with the common sense. We are given the matrices P, Q, R, S with these orders. So we can merge these in, we can multiply these in 5 different ways as per the order. They are, you can multiply P into Q, then R into S, both can be multiplied, right? This is one way. The other way is, first multiply P and Q, multiply that with R, whole multiply with S. This is one possibility. Other possibility, multiply Q and R first, multiply that with P, finally with S, then multiply Q and R, then with S, then with P. Multiply R and S, that you multiply with Q, then with P. These are the 5 different possibilities in which we can do the multiplication, right? Now, P and Q when you multiply, P and Q when you multiply, the number of multiplications would be 2 into 3 into 4. This produces 2 by 4 matrix. Now, R into S, 4 into 3 into 2. That produces 4 by 2 matrix. Now, both when you multiply 2 into 4 into 2. So, this would be 2 3s are 6, 6 4s are 24 plus 24 plus 16. So, this would be 64 number of multiplications. Now, second one, let's see. For PQ, 2 into 3 into 4 multiplications, that produce 2 by 4 matrix, that you are multiplying with R. So, 2 into 4 into 3, this produces 2 by 3 matrix, that you are multiplying with S. So, 2 into 3 into 2. So, this would be 24 plus 12. This would be 60 multiplications. Now, the third possibility, 3 by 4 by 3 plus, this produce 3 by 3 matrix Q into R. Now, 2 into 3 into 3 plus 2 into 3 into 2. So, this would be 4 9s are 36 plus 18 plus 12. 66 multiplications. Now, here 3 4 3 plus 3 into 3 into 2 plus 2 into 3 into 2. So, this would be 36 plus 18 plus again 66 multiplications. Now, finally, R into S, 4 into 3 into 2 number of multiplications plus 3 into 4 into 2 plus 2 into 3 into 2. So, this would be 4 3s are 12, 12 2s are 24, 24, 12. So, this would be 60. So, the minimum number of multiplications in this second and fifth. So, what we are doing the multiplication first, here RS, here PQ. So, either the first product can be P into Q or R into S. So, A, D you have to select. Understood? Let's proceed to next question.
So here comes question number 21 for this mini mock test from the subject compiler design. This is the question from lexical analysis. Please try to solve the question and watch the solution once you are done. Consider the following C statement. Printf, this is your string and this particular thing. Now, the number of tokens in the above C statement are, how many tokens are there in this particular C statement? Please, 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 please. When I say printf, this is one token. This is the first token. This opening bracket will be a second token. Done. Then this whole thing within this double quote is a string constant. So count token percentage T. This is your third token. This comma will be your fourth token. So up till this point of time, everything is good. That everybody will be able to tell that, okay sir, printf in one token, this is second token, this third token, this fourth token. Problem starts from here, that how many tokens are there. So with respect to plus plus plus, what will happen? Sir, plus plus, we try to match the longest pattern. I hope you know that. So plus plus is the longest pattern which matches with the operation. Therefore, plus plus will become one token. Then, so this two will become one token. Then plus and end is not any operation or not any token. Only plus is the token which is the longest matching pattern. Therefore, this plus will become a new token, that is sixth token. Then what, sir? Then, sir, this will become, this is AND operation. So this will become your seventh token. Okay, so this is one, this two will become one. So now, sir, what happens with this triple asterisk? So, is there any operation asterisk asterisk defined in the C language? No, sir. Plus plus is defined in the C language. Minus minus is defined in the C language. But asterisk asterisk is not any operation. Clear? So, asterisk asterisk is not an operation. Therefore, this asterisk will be one token. Next asterisk will be another token. Next asterisk will be another token. So, it will be 8th, 9th and 10th token. After that, this P is your 11th token. This closing bracket will be your 12th token, and this semicolon will be your 13th token. So how many tokens are there? So number of tokens in the given C statement are 13. Clear? Very easy, but you just need to know these two things, that how this plus 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 will be divided into tokens, how asterisk 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 will be divided into tokens, and that's all is there in this question. Okay, let's move to the question number 22 of the compiler design. Very easy. So consider the following grammar G. So these are the statements of the grammar G, productions of the grammar G. Now it is saying LL1 and SLR1. It is asking for two things, LL1, SLR1, LL1, SLR1, LL1, SLR1. So what is the grammar? So the grammar is S implies A, B and B, A. B, A. Apart from that, A implies epsilon, B implies epsilon. So first check for LL1. So I've already told you what? Sir, if the productions are unit productions or the single productions, then the grammar is guaranteed. I mean, those will not create any problem. So, okay with respect to LL1. Now, what about this? So, for this to be LL1, the intersection of the first of A, B, this is your alpha 1 intersection with first of B, A should be 5. So let's look at the first of alpha 1 and first of alpha 2, that is first. So what is first of A, B? So first of A is epsilon, but does it mean that the first of this thing is epsilon? No, sir. If first of A contains epsilon, then you will subtract epsilon and you will check for the first of remaining thing. Therefore, first of A, B is A, and first of B, A is B. So you know A intersection B is coming out as pi. Therefore, it is also okay with respect to LL1. So all the productions of S, A and B are satisfying the condition of LL1. Therefore, yes, this grammar G is LL1. This grammar G is LL1. Now let's check for SLR1. SLR1. Sir, it is quite easy to observe that what will happen in the initial state itself when you try to construct the DFA of LR0 items, you will start with S dash implies dot S. Now, because of this dot S, you will add all the productions of S, that is S dot A, B. You will add S implies dot B, A. Right, and then you will, because of this dot A, you will add the production of A implies epsilon. A implies epsilon is the same as A implies epsilon dot, right? Ready to see nothing, seen nothing, ready to see nothing. Similarly, B implies dot epsilon is the same as B implies epsilon dot. So in this state, initial state itself, there are two productions which are ready to be reduced. Now let's look at the idea. So with respect to this particular production, we will place the reduced entries corresponding to the terminals which are present in the follow set of A. So what is follow of A? What is follow of A? So follow of A is terminal A as well as terminal B. With respect to this, we will make the entries on the terminals which are present in the follow of B. So follow of B is also B comma A. Now you can check, you can actually see follow of A intersection with follow of B is not equals to phi. It means in the same state 0, there will be reduced entries with respect to A implies epsilon on the terminals A and B, and in the same state 0, there will be reduced entries with respect to B implies epsilon on the terminals A and B. Therefore, there will be reduced entries in the same, reduced conflict in the SLR1 parsing table. So therefore, not SLR1. Cool enough, easy one, right? So this grammar is LL1 but not SLR1. So G is both LL1? No, G is LL1 but not SLR1. Yes, G is LL1 but not SLR1. Correct answer is option B. Okay, let's move to the next question, that is question number 23. Okay, so it is a multiple select type of question, multiple select question. Which of the following statement is R false? Which of the following statement is R false? If grammar is not LA-LR1 grammar, it is given that the grammar is not LA-LR1 grammar and it has shift reduce conflict. It is also saying that it is not LA-LR1 and it is having a shift reduce conflict. Then it can never be CLR1 grammar. So you know, a grammar which is not LA-LR1 may or may not be CLR. A grammar which is not LA-LR1 may or may not be CLR1, but if the grammar is not CLR1, it is guaranteed that it will not be LA-LR1. It is given that the grammar is not LA-LR1, so it may or may not be CLR1, but it is saying that it can never be CLR1. It can never be CLR1. Is it the correct statement? Yes, sir, it is the correct statement. Why? Because if there exists a shift reduce conflict in the LA-LR1 states of the LA-LR1 DFA, then that shift reduce conflict will also exist in the CLR1 because LA-LR1 is nothing but the merging of two states of the DFA of LR1 items with respect to CLR1 parser. Now what will happen? In LA-LR1, the shift reduce conflict can exist if and only if that shift reduce conflict exists in the DFA of LR1 items with respect to CLR1 parser. If there is no SR conflict in CLR1, then there will be no SR conflict in LA-LR1. Clear? So, if there is a shift reduce conflict in LA-LR1, then it can happen only when that SR conflict also exists in CLR1. Therefore, it can never be a CLR1. This statement is true. It is asking for a false statement. So, this statement is true. Now, If grammar is not LALR1 and it has reduce conflict, then it can never be CLR1 grammar. No. The reduce conflict may exist in the LALR parser even when there is no reduce conflict in the CLR1 parsing table. Therefore, if there exists reduce conflict, then also it is possible for some grammars that there is no reduce conflict in the CLR1 and it may be CLR1 grammar. Therefore, this statement is false. Clear? Next, if the grammar is not LALR1, it is saying the grammar is not LALR1, then it can never be LL1. Is it so? Please try to understand. What did we say? So these are the grammars. LR0, SLR1. So I hope you remember that this is nothing but LR0, this is SLR1, this is LALR1, and this is CLR1. Now, if somebody asks you for the entries with respect to LL1, so these are the grammars which are LL1 grammars. These are the grammars which are LL1 grammars. Now, try to understand this point. If a grammar is not LALR1, means if the grammar is outside this region, can it not be LL1? If the grammar is not LALR1, can it not be LL1? Sir, there are some grammars which are not LALR1 grammar but CLR1 grammar, and they may also be LL1. They may also be LL1. So, this is a very close call to take. If grammar is not LALR1 grammar, then it can never be LL1. This statement is wrong. So, there are some grammars which are not LALR1 but still LL1. So, this is also a false statement. What about the third statement? If grammar is not CLR1 grammar, it is saying if the grammar is not CLR1 grammar, then it can never be parsed using any bottom-up parser. If the grammar is not CLR1 grammar, then it can never be parsed. It can never be parsed using any bottom-up parser. CLR1, LR0, they are all the bottom-up parsers, and CLR1 is the most powerful parser among them. CLR1 is the most powerful parser among them. Now it is saying if the grammar is not CLR1, that it cannot be parsed using the CLR1 parser, then it can never be parsed using any bottom-up parser. No. There are two logics. If we increase the value of this k, then possibly some other bottom-up parser may parse the given grammar, and apart from that, if the grammar is ambiguous grammar, then CLR1 parser will not be able to parse it for any value of k. But still, there are some bottom-up parsers like operator precedence parser which can parse them. Therefore, this statement is also false. This statement is also false. So, which of the following statements are false? Or statement B is false, as well as statement C is false, as well as statement D is false. Such type of questions can be asked in 2 marks because the chances of skipping one, if there are multiple correct answers, then chances of skipping some of them is possible. Clear? So, this is your question number 23 from the compiler design. Okay, here is question number 24 from the subject database management system for this mini mock test. So, the question is, consider three relations are, just a minute, sorry, consider three relations are with attributes A, B, C such that A is the primary key, relation S with attributes A, D, E such that A and D together forms the candidate key, and relation T such that with attributes G and F in which D is the primary key. Okay, so R has 40 tuples, S has 30 tuples, and T has 50 tuples. Now it is asking for the number of tuples in natural join of R, S and T. So guys, for this particular type of question, just remember one thing. If there is a relation R1 with attributes A, B, and whatever, C, And let's assume A is the primary key. And there is another relation R2 which also consists of attribute A, and let's assume some other attribute D, such that this A is the foreign key and it is referring to the primary key of relation R1. Then please look at this, that these two things together means A alone is not a key, but the combination of A and D is a key. So, there is a scenario, please try to understand that this A is a primary key. Here, A and D together is a primary key. So, you can eventually think of a situation. Let's assume that we have a relation student in which SID and some other information will be there. You have a course table in which CID and some other things will be there. So SID is the key of this relation student. CID is the key of this relation course. And if I define a relation enroll, then in the enroll, the student with SID enrolls for a course with CID at some other attributes. So these two things together will form a candidate key for this relation enroll. Now the idea is that this SIDs will be from relation student, this CIDs will be from relation course. So here also the similar type of situation is there, that this A and D are the foreign keys, where A is the foreign key which is referring to the primary key of relation R. This D is the foreign key in the relation S which is referring to the primary key of relation T, right? So if this is the situation that R1 has an attribute A and that attribute is a foreign key in some other relation R2, and if we perform the natural join of these two relations, then what will happen? So every tuple of relation R2, every tuple, because whatever the values of A are there in the relation R2 are from the values of attribute A in the relation R1. So when we perform the natural join, then every tuple of relation R2 will match with exactly one tuple, because that particular key will be appearing only at one place in relation R1, because A is the candidate key or primary key. Getting the idea? So every tuple of relation R2 will match with exactly one tuple of relation R1. There will be no other matching. So the number of tuples will be exactly same as number of tuples in relation R2. So that's the idea, that if we first perform the natural join of R and S, then we will get how many tuples are. A is the foreign key referring to the primary key of relation R. So we'll check for the equality between these two attributes and exactly how many tuples, exactly all the tuples of relation S will match with exactly one tuple of relation R. So in this natural join, the number of tuples will be exactly same as number of tuples in relation S, that is 30. Now, when we perform the natural join of this resultant with the relation T, then what will happen? Sir, R natural join S will have how many tuples? So it will eventually have 30 tuples. Yes. And what are the attributes? So the attributes are A, B, C, D, E. A, B, C, D, E. Here we have D and F. So this D in this relation R natural join S will also be the foreign key for relation T. Therefore, after this natural join, again we will get 30 tuples, because each tuple of this R natural join S will match with exactly one tuple of relation T. So the number of tuples will be same as the number of tuples in R natural join with S. So the answer for this question will be 30. So just remember one thing, whenever the question is related to the number of tuples in the natural join, then please make sure the number of tuples will be exactly same as the number of tuples in the relation with which contains the foreign key. Clear? Okay. Next is the question number 25. Look at this. Consider the following relational schema. So there is a relation R with attributes A, B, C, D, E, F with the following FD set. So these are the FDs. Now it is asking, if we decompose the above relation into B, C and F, then how many sub-relations are created? So this question is related to the concept of decomposition, that how many sub-relations will be created. So let's look at this. There is a relation R with attributes A, B, C, D, E, F. Now, what are the FDs, sir? Let's look at the FDs. A implies CF, C implies D, B implies E. A implies CF, C implies D, B implies E. If we find the candidate key, so what is the candidate key? Sir, look at the right hand side. A and B are the essential attributes, so A and B must be present in every candidate key. Now, let's look for the closure of A and B. Closure of A and B is nothing but A, B, and from A you can get C and E. From C you can get D and F. This is F. This is F. C, F. Just 1 minute. This is F. Clear? So A, B, C, F, D, and because of B, you will get E. So all attributes are present and these are the essential attributes. So don't check for proper subset. This is the candidate key. Do we have any other candidate key? Please look at this FD set. There is no FD in which the prime attributes A or B are appearing in the right hand side part. Therefore, there will be a single candidate key, that is AB. Now, with respect to that, sir, what is the normal form of this particular FD? Sir, it is in 1NF. Yes or no? Proper subset of a candidate key defining non-prime attributes 1NF. This non-prime attribute to non-prime attribute, it is in 2NF. B is a proper subset of a candidate key defining a non-prime attribute 1NF. So, eventually, in the given relation, the normal form of the relation is 1NF. Therefore, we need to decompose it up to BCNF. So, first of all, let's decompose it with respect to anyone you can take. Let's assume that decompose with respect to ACF. Now, please, if we are taking with respect to A implies CF, then also check for the closure of CF. Closure of CF is D, contains D. Therefore, you will also have to include D. You will also have to include D. What are the FDs of this particular set? So, the FD of this particular set will be A implies CF and C implies D. Okay. Now, so what are the leftover attributes? The attributes will be B and E. B and E. But to make this decomposition lossless, the candidate key of this relation is A. Candidate key is A. Therefore, you will have to include A. Now, at this point of time, this one is in BCNF. This C implies D is still in 2NF, but that's fine. But what are the FDs of this particular set? So the only FD in this particular set is B implies E. B implies E. So what will be the candidate key of this relation? So candidate key of this relation is still EB. What is the normal form of this relation? So B implies E is still in 1NF. Okay. So done. Up to this point of time, that's fine. But let's try to decompose this into 2NF. So it is in 1NF because of B implies E. So just decompose it with respect to BE. Done. So BE. So only FD will be B implies E. We are left with only one attribute, that is A. Now to make this decomposition lossless, we will add B. Right. So here the candidate key is B and this is in BCNF. Perfectly right. So do we have any non-trivial FD for this relation AB? No, sir. No non-trivial FD. So if there is any relation with no non-trivial FD, then the relation is in BCNF. So, sir, this decomposition is BCNF, but this is still in 2NF. So let's decompose it for 3NF. Let's decompose it for 3NF. And let's see what happens if we decompose it for 3NF. So it is not in 3NF because of C implies D. Therefore, decompose it with respect to CD. So if we decompose it with respect to CD, you will get C implies D and the candidate key will come out as C. Therefore, it will be in BCNF. Now let's look for the leftover attributes. If we are done with C and D, then we will be left with A and F. But to make this decomposition lossless, just add the candidate key of this relation CD. So this becomes ACF. Now, the FD of this particular relation will be A implies CF. Again, the candidate key is A. Therefore, this is also in BCNF. So you can actually check that after this decomposition, all these subrelations are in BCNF. That is, the database is in BCNF. database is in BCNF, and how many subrelations are created? So 4 subrelations are created. 4 subrelations are created with respect to this. Okay, let's look at the question number 26. Please try to solve this. This is related to the concept of serializability. Consider the following 2 schedules involving 3 transactions. So there are 2 schedules, S1 and S2, and in each schedule there are 3 transactions. It is asking that whether S1 is serializable or not, S2 is serializable or not. So how do we check that? So there are 2 ways. If the conflict serializable schedule, then it will be serializable. If it is not conflict serializable, then it may or may not be serializable. So if it is not conflict serializable, then you will have to check for view serializability. If the schedule is view serializable, then it is guaranteed to be conflict serializable. If the schedule is view serializable, then it is guaranteed to be a serializable schedule. Okay, so let's check them one by one. So what is the schedule S1? There are transactions T1, T2, T3, and R1A, R2A. So first operation is with respect to transaction T1, then with respect to transaction T2, R1A, R2A, W3A, W1A. This is W3A and W1A. Now check for this schedule. Is this schedule conflict serializable, sir? R1A and W3A, that is T1 to T3, and T3A, W3A and W1A, that is T3 to T1. So it is not conflict serializable schedule, obviously. Not a conflict serializable schedule. Now let's check for view serializability. Is it a view serializable schedule? Is it a view serializable schedule? Now please try to understand this. Please try to understand this. Please, please, please. Sir, the final update is by transaction T1. So it says that T1 must appear in the end, because if T1 is not in the end, then the final updation of the data item A cannot be done by the transaction T1. And the final update must be in the equivalent serial schedule. The final update must be by transaction T1. But the problem is, if the transaction T1 comes at the end, then transaction T3 will eventually appear before transaction T1, and if transaction T3 starts appearing before transaction T1, then this T1 will not read the value from the initial database, but transaction T1 will start reading the value updated by this transaction T3. Therefore, you cannot keep T3 before T1. You cannot keep T3 before T1 and ensure that the behavior is exactly same as schedule S1. Therefore, T1 should come in the end and T3 should not come before T1. T1 should come in the end and T3 should not come before T1. This is not possible. Therefore, not view serializable schedule as well. Not view serializable schedule. So this schedule is neither conflict serializable schedule, not view serializable schedule. Therefore, we can say that this schedule S1 is not serializable. Where did it go? Let's look at schedule S2, R2B, R2A. So let me first draw this T1, T2, T3, S2, R2B, R2A, both are from transaction T2, R2B, R2A, W1B, R3C, W1B, R3C, W2B, W3B, W2B, and then W3B. So tell me, is this schedule conflict serializable schedule? Please check. Is this schedule conflict serializable schedule? So you can actually see this is read B and write B, and this is write B and write B. So not conflict serializable. Done, sir. Not conflict serializable. Does it mean that it is not serializable? We are not sure. We need to check for view serializability. So let's look at this thing. Let's check for view serializability. So this write of data item B is finally done by transition T3 in schedule S2. Therefore, in the equivalent serial schedule also T3 must appear in the end. Okay, T3 should come in the end. Now, apart from that, this transition T2 reads the data item B and A from the initial database. Therefore, there's a read of data item B in the transition T2. Therefore, transition T2 must appear before transaction T1 and T3. So T2 must appear T1 and T3. After T2, the T1 transaction T1 may appear. Now please try to understand. You may say, sir, if T1 appears after T2, then this one is fine. But because of this, T2 should not come before T1. T2 should not come before T1. No, but this is a blind write. There is a blind write in transaction T3. There is a blind write in transaction T3. So whatever happens, the intermediate write operation of data item B are not important. Intermediate write of data item B are not important. At least blind write on data item B are not important. The final writer of data item B matters. So in this case, if you look at this schedule T2, T1, T3, then this is a serial schedule whose behavior will be exactly same as schedule S2. Whose behavior will be exactly same as schedule S2. So you can actually see in T2, the read of data item B should be from initial database. Read of data item A should be from initial database. It will happen with respect to T2 also. Now, no one else is writing the data item C. Therefore, no matter where exactly you place the transaction T3, this read of data item C will also be from initial database. So all reads are fine. Now let's look with respect to write of data item B. Now, with respect to this schedule S2, the final operation of data item B must be by transaction T3, and this is happening in this serial schedule also. Therefore, S2 is actually equivalent to serial schedule T2, T1, T3, therefore serializable. So what can we say? Schedule S1 is not serializable schedule, but schedule S2 is a serializable schedule. So S1 is not serializable and S2 is serializable. So the correct answer is option B for this question. Okay. Here is your question number 27 from the concept of B tree and B plus tree of database management system. Let's try to solve this. In a B tree, if the search key is 8 byte long, record pointer is a 12 byte long, block pointer is also 12 byte long, and the block size is 512 byte, then the maximum order of B tree. What is the order of B tree? Order of B tree in general, if nothing is specified, then the number of children a node of B tree can have. The number of children a node of B tree can have. So what's the context here, sir? In a node of B tree, how do we define it? This is a block pointer 1. There is a key 1. There is a record pointer R1 with respect to key 1. Now what happens? Sir, all the records whose value is less than this value K1 will be pointed by this block pointer B1. K1 will be pointed by this record pointer R1, and all the values B2, K2, R2. So all the records whose key value are greater than K1 and less than K2 will be pointed, the information corresponding to them will be pointed by a block which is being pointed by this block pointer B2, etc. and so on. This will keep happening. The last one is, let's say, assume BP, right? So before that you will have key KP minus 1 and record pointer with respect to key P minus 1. Clear? So that's the idea. This is the structure of a node of B tree. Now how many childs are there? B1, B2, B3 up to BP. So let's assume, let order is P. Let order of a node of B tree is P. Now, this is actually nothing but a disk block. All this information is stored in a disk block. And we know that the disk block is of size 512 byte. So, how much information of this type can be stored in a block of 512 byte? That's what we need to see. So let's assume the order is P. So what will happen? Sir, in a node of B tree, if the order is P, then there will be P block pointers and P minus 1 keys. With respect to each key, there will be record pointers. So P minus 1 keys and P minus 1 record pointers will be there. So sir, what do we know? Sir, P block pointer will be there, plus P minus 1 key plus record pointer will be there. And all that must be less than or equals to the disk block size. It should not go beyond the capability of the disk block. Right? So, let's assume the order is P. So, block pointer size we know given as 12. Yes, 12 and 8 and 512. Right. So, block pointer size is 12. This is P minus 1. Key size is given as 12. Key size is given as 8. Record pointer size is again given as 12. And this overall value has to be less than the block size, that is 512 byte. Clear? So when we solve this, this is nothing but 12p plus 20p minus 20 should be less than 512. So sir, this comes out as 32p should be less than or equals to 532. That is, P must be less than or equals to 532 by 32. So how much is this? 532 by 32. So this comes out as 16.625. 16.625. So, no matter what, if you want to store this information into a disk block of 512 byte, then the value of P cannot be greater than this value 16.625. Now, the value of P cannot be in fraction, so the maximum possible value, which is less than this value 16.625, is actually 16. Therefore, the maximum order of a node of B tree can be 16. Maximum order of a node of B tree can be 16. So this will be 16. So that will be all from the questions of database management system.
Here is question number 28 of Independence Day special mini mock test of computer science. Yes, consider an IP address 192.161. so and so. Pick correct statement or statements from below with regard to given IP. It is a multiple select question for 2 marks, dear friends. So, first pause the video, solve it for yourself, then check the solution. The given IP address is 192.161.120.224/28. Now, if you see the options, the subnet address, first host address, broadcast address, first host address is what we have to find out. So, if you see from this /28, we can understand 32 minus 28. That is 4 bits represent host ID. Right? So 192.161.120. These represent network ID, subnetwork ID. These 4 bits represent host ID. Now, what is the first IP that is possible with this? All zeros. But we know this is used as network address. So what would be the first host address? 0001. And what would be the last host address, which is broadcast or DBA address? All ones. So now just write this prefix as it is. That is the first IP. This is the first host address. This is the last host address or broadcast address. So this is 192.161.120. What is this? 224. So 192.161.120.224, the first host address? No, it is the first address, so subnet address, correct. Then first host address is 224 plus 1, 225, right? 192.161.120.225. So first host address is 225, correct. And the last host address 192.161.120. This is 15 plus 224, 239. But here it is given 255, so wrong. So what are correct? A, B. Got it? Question number 29. Consider an instance of TCP's AIMD algorithm with segment size 200 bytes, advertised window size 2000 bytes. After fourth transmission, if the sender received only one acknowledgement, how many bytes sender prepare to send to the receiver? It's a numerical answer type for 2 marks. First you solve it, then check the solution. Okay. Given advertised window size as 2000 bytes, okay, segment size 200 bytes. So in the first transmission, one segment is sent whose size is 200 bytes. Once its acknowledgement come, sender add more 200 bytes. So now sender send 2 segments, that becomes 400 bytes. Now once he get the first acknowledgement, sender will add plus 200 bytes. Second segment acknowledgement, sender add more 200 bytes. So in the third transmission, sender is sending 4 segments whose size is 800 bytes. Now, one segment acknowledgement received. One segment acknowledgement received. Now sender will add more 200. So now what is the window size became 1000 bytes. Here is the threshold. So in the fourth transmission, sender will send only 5 segments. After fourth transmission, sender got only one acknowledgement. So already there is 1000 plus. Now whenever threshold comes, additive increase phase is what done. As 5 segments sent, after 5 acknowledgements 200 bytes would be added, but now 200 by 5 bytes would be added. So that is 1000 plus 40 bytes. So sender would be preparing how much data after one acknowledgement is received? 1040 bytes of data. So answer is 1040. This is a slow start phase. This is additive increase phase. Got it? The last question of Independence Day special mini mock test for GATE 2024 aspirants of computer science is on your screen. Consider an IP datagram with header prefix 4E, 7B, so on. The payload present in the datagram is dash bytes. It's a NEAT question for 1 mark. Solve it, then check the solution. This is the header prefix, right? So here in 4E, 7B, 63EA, 1A, C2, 00, so on, 4 represents version and E represents HLEN value, right? 7B represents type of service and 63 represents total length. Wait, not total length. 63EA. Total length is 16 bytes, no? So this 16 bits represents total length. Now E is HLEN, that is 14 is HLEN, that is header length is HLEN multiplied by 4. Multiplied by 4, 56 bytes. Now 63EA in hexa, convert it into decimal. That is A into 16 power 0 plus E into 16 power 1 plus 3 into 16 square plus 6 into 16 cube. So this is A plus 14 into 16. You can use calculator. I am also doing the same. 14 multiplied by 16, 224 plus 16 square into 3, 768 plus 16 cube, into 6, 24,576. You have to add all these plus 768 plus 224 plus 10. That is 25,578 we are getting. This is the total length. Now payload length is equal to total length minus header length. So this is 25,578 minus 56. How much? 25,522. 25522 is the answer. So you have to enter this numerical value 25522. Got it? So hope you enjoyed this mini mock test solving all these 30 good questions on the Independence Day. So BYJU'S exam prep brought this special useful mini mock test for you on this special day, Independence Day. Hope your subjects, all subjects got revised and practice. This mini mock test made the practice better. I wish you all a very happy Independence Day. Thank you all. See you in the next session. Till then, keep liking the session, share and subscribe to our BEP YouTube channel and enable the notifications. See you in the next session. Till then, have a great time. Take care. Once again, a very happy Independence Day. Bye-bye. Thank you.